Good afternoon, everyone. Myself, Dr. Ankita Mazumder, Assistant Professor of Chemical Engineering Department, Haldia Institute of Technology. So today we will discuss about a very important topic of heat transfer, that is the evaporation. So in today's lecture, we will discuss about the fundamental concept of the evaporation, and we will discuss about the construction of evaporator, about its operation, how we can characterize the or categorize the uh, evaporator into different types based on its alignment, construction or configuration. Also we will discuss how evaporation is different from other heat transfer operations like boiling, vaporization, and also we will discuss about the single effect evaporator and the multiple effect evaporator, and when to choose which type of evaporators. And also we will discuss about some significant performance evaluation parameters of the evaporation process. So let's start the basic concepts of the evaporation. So evaporation is basically done to concentrate any non-volatile solute from a solution mixture, specifically if water is being present as the solvent. So from the diagram itself you can see here we are feeding here cold feed, and also we are introducing what? Steam is used. Why steam is used here? To because steam will lose its heat, mainly the latent heat in most of the cases, and that latent heat will be consumed by these cold feed to increase its temperature to the boiling point. When it will reaches and ultimately what will happen, the boiling of this feed will take place, and ultimately the water will be vaporized into the water vapor, and it will be collected from the top of the evaporator. And as the steam loses its heat, what will happen? After the process we will collect out the condensate, and from the bottom of the evaporator we will take out the concentrated liquor. Now what is the concentrated liquor? Means what happens, whatever solute was initially present in the solution mixture, now as the solvent is gradually evaporated, what happens, the concentration of the solute will increase in the mixture, and as a result we are calling it as the concentrated liquid. So what happens, in the basic objective of the evaporation is now clear to us. That means to concentrate a solution we mainly carry out the evaporation process. Now in the next slide we will see how the evaporation is different from the other heat transfer operations like boiling. As we know that boiling is such type of process where what happens that liquid boiling takes place when the liquid reaches its boiling point. If it does not reach its boiling point, we know that boiling does not take place. However, in case of the evaporation can take place at any temperature. Suppose at room temperature also evaporation can take place. If we take the example of the sea water, everybody knows that evaporation of the seawater takes place at summer also, at spring also, at winter also. And with the change of the season, what we know, the temperature, our ambient temperature also changes. But in every season, what we see that in every season evaporation takes place. So from here also we can understand that evaporation does not depends upon the temperature. Whatever may be the temperature, some amount of evaporation will always take place. So evaporation, we can conclude that evaporation can take place at any temperature. However, in case of boiling, what happens? Boiling cannot take place at any temperature. We should ensure that the boiling must reach the boiling point of liquid, otherwise boiling phenomena will not take place. Another significant difference between the evaporation and boiling is that evaporation mainly take place from the surface of the liquid. That means from the top of the liquid. It is not a bulk phenomena. Whereas in case of boiling, when the boiling takes place, if we boil water in some bowl, what happens? Entire liquid, when entire water starts to boil, the bulk phenomena is taking place. Only the boiling from the top surface does not take place. So here also this is a very distinct difference between the evaporation and boiling. That is, evaporation is a surface phenomena, whereas the boiling is a bulk phenomenon. Another thing you have seen that during the summer season, when we sweat, what happens after some time? When the sweat evaporates or vaporizes, what happens? At that place we feel the coldness. Why? Because the temperature of the body decreases. So when the evaporation takes place, the temperature of that body starts to decrease. But such type of phenomena does not take place in case of the boiling phenomena. Now another difference, if we have heard about another term, that is the vaporization. Now we can discuss that how evaporation is different from the vaporization. Basically, if we consider the principle, both the principle are alike. But the main difference is, if the water gets vaporized, then we call that phenomena as the evaporation. But suppose some organic liquids or other type of liquids gets vaporized, then we call it as the vaporization. So basic fundamental is almost similar, but the depending upon the solvent, we can give it the different name. That is, the if water is solvent, then we call it as the evaporation. If some other type of liquid are present, then we call it as the vaporization. So now let us consider as the what is evaporator. Evaporator is what? Evaporator mainly consists of a heat exchanger. Why heat exchanger is there? Because for the vaporizing the water to water vapor, this heat exchanger is used. So how the vaporization takes place? We already discussed that whatever may be the feed temperature, it will consume heat from the provided steam. So steam will lose its heat, and that heat will be consumed by the feed to increase its temperature to the boiling point. So after the boiling point, when it will reach the boiling point, what will happen? The vaporization will take place, and ultimately the water will be converted to water vapor, and it will be taken out from the top of the evaporator. And as a result, as the water content decreases from the solution mixture, the concentration of the solute in the evaporator ultimately starts to increase, and the given steam is ultimately collected as the condensate after the process. Now in case of evaporator, we can categorize evaporator into different types. Suppose if we consider the alignment and the length of the evaporator tubes, we can categorize them into some types. Also, depending upon the number of effects, we can categorize or classify the evaporators into single effect evaporator or multiple effect evaporators. Likewise, depending upon different bases, we can categorize the evaporator. And another important point which needed to know regarding the evaporator is that in many cases what we see within the evaporator, we decrease the temperature. Why we decrease the pressure within the evaporator? Why? As we know, if we decrease the pressure, boiling point of any liquid starts to decrease. Whereas contrarily, if we increase the pressure of a system, what happens within that system? The boiling point of the solution will starts to increase. So what happens, since sometimes the materials of evaporators cannot tolerate a very high temperature, in such scenario what we do, we reduce the pressure within the evaporator. So as a result, what happens? The boiling point of the liquid will start to decrease. So this is an important point which needs to be considered, which is generally followed in case of an evaporator. So here we will discuss about the types of evaporators. So mainly in this slide we will see that depending upon the alignment of the evaporator tubes, we are classifying them into two types. First one is the horizontal type, another one is the vertical tube type. What happens if we see this figure A, we can see that the evaporator tubes are aligned in the horizontal type. Whereas in the second figure, what we can see, evaporator tubes are aligned in a vertical manner. So accordingly, we have classified them into two types. One is horizontal tube and another one is the vertical tube evaporator. So let us see this picture, what is happening. So here we are introducing the feed system, and on this side we are introducing the steam. And after evaporation will take place within these evaporator tubes, and ultimately what will happen? Water will be vaporized and are be collected as the from the top as the vapor, whereas the concentrated solute will be collected from the bottom of the evaporator, and as the steam loses its heat, ultimately we will collect it as the condensate, as we have discussed already in the previous slide. The similar type of operations takes place in vertical tube evaporators also. Main difference is on the alignment of the tubes. Here you can see it is horizontal, whereas here you can see it is the these tubes are aligned vertically. So moving to the next slide, here we can see another two types of evaporators are there. These are what long tube particle types, and another one is the forced circulation type. So here what you can see, these evaporator tubes are quite long. That's why we are categorizing them as the long tube particle type evaporators. Whereas in this side, in this figure also you can see the main difference is what here we are force circulating the feed. That's why we are calling it as the force circulation type of evaporators. So I think it is clear now that depending upon the alignment and the length of the evaporator tubes, we can classify them into four types. First one is horizontal, second one is vertical, and the third one is the long tube vertical type, and another one is the force circulation. That means some by force we are circulating the feed. That's why this is the force circulation type. Now here I have already discussed that depending upon the number of effects, we can again classify the evaporators. So how we can classify? We can classify them as the single effect and the multiple effect evaporation. So what happens in the single effect evaporator? A single evaporator is there. That means single effect is there. No more than one effect is there. That's why we are calling them as the single effect. In single effect, evaporation process is taking place. Whereas in case of the multiple effect evaporation, more than one effect will be there. That means more than one evaporator will be present in that evaporation. So how we can number that the effect 1, effect 2, effect 3 likewise. So the effect in which the first steam will be introduced, that effect will be numbered as the 1. We will not number the effect depending upon the feed introduction. Rather, we will number them on the introduction of steam. In whatever the effect where we will first introduce the steam, we will number them as the effect 1. The next one will be effect 2. The consecutive one will be effect 3. Likewise, we will carry out the process. Now comes how this multiple effect evaporation takes place. What happens in the first effect 1, what we do, we will introduce the steam. It will lose its entire heat, and ultimately vapor from the effect 1 will be produced, and that vapor will be used as a heat source for the second effect. And again evaporation will take place and some vapor will be produced, and that vapor produced from the effect 2 will be consecutively used in the effect 3 as the heat source. Likewise it will go. So what happens here in case of the multiple effect, the steam will be introduced in one effect only, but the vapor from consecutive evaporators will be used as the heating source. And in case of the multiple effect evaporation, one thing is needed to be considered, that generally all the evaporators will be physically same. That means in terms of either we consider size, their construction material, their heat transfer area, all these things will be maintained constant in case of multiple effect evaporator. And also if the thermal losses are not significant, then we can see that the capacity of the multiple effect evaporator generally remains same as the single effect evaporator. But if the thermal losses are significant, then we see that the capacity of the multiple effect evaporator generally decreases as compared to the single effect evaporator. That we will discuss in detail in the coming slides. So here we have just we have introduced ourselves with that how the single effect evaporator is different from the multiple effect evaporation. Now to evaluate any performance of any evaporator, we should accustomed with the some terms, some important terms. What are they? They are the first one is the capacity of the evaporator, second one is the steam economy, and the third one is the steam consumption. So regarding the capacity, what is capacity? Capacity is how much kg of water is being vaporized per unit time. That means kg of water vaporized per unit time, or in other term you can say that the kg of water vapor produced per unit time. So I think the capacity is clear to everyone. Next important term is the steam economy. What is steam economy? That means how much kg of water has been vaporized when we are per unit kg of steam input. Suppose we have given 1 kg steam input. So for 1 kg steam input, how much kg of water vapor has been produced, or how much amount of water has been vaporized. So it is not that we are giving 1 kg of steam and we are producing 1 kg of water vapor. It does not happen like that. Always generally in steam economy of the single effect evaporator, what we are seeing that steam economy is always less than 1. That means if we are giving 1 kg of steam, it will not produce 1 kg of water vapor. It will produce less amount of water vapor. So I think the concept of steam economy is already clear. That means how much steam we are giving, and with this steam how much water vapor we can produce. This is the ratio of these two is known as the steam economy. And the third parameter is steam consumption. So from the name itself we can see that that means how much steam is being consumed per hour. Clear? So uh, in a unit time, how much kg of steam we are consuming in an evaporator, that has been represented by the parameter steam consumption. So steam consumption is nothing but the ratio of the capacity by the steam economy, capacity to the steam economy. So basically economy calculations are mainly done using the enthalpy balances, and this steam economy is a very steam economy and capacity of the evaporator are the quite important terms for understanding the performance of any evaporator. So what we have seen that for a single effect evaporator, the steam economy is always less than 1. Clear? So it will never be 1, or it will never be greater than 1 in case of a single effect evaporator. However, we will see later on that in case of multiple effect evaporator, the steam economy will be greater than the 1, that we will see in the coming slides. So now in this slide we will discuss that why multiple effect is evaporator is selected sometimes over the single effect evaporator. What is the what are the main advantages if we use multiple effect evaporator uh, in place of the single effect evaporator? So in the previous slide, what we have discussed that steam economy of single effect evaporator is always less than 1. Now this is a schematic representation of the multiple effect evaporator. So you can see here, this is the effect 1, this is the effect 2, this is the effect 3. Now what we have already known that how we can number effect 1, effect 2 and effect 3. The effect where the first the steam will be introduced. We can see we are introducing steam in this evaporator. So we will call it as the effect 1. The next evaporator will be numbered as the effect 2 and the next one as the effect 3. So here we are considering 3 effect for the multiple effect evaporation. So here you can see in the first effect what is happening. We are giving the steam also, we are feeding, we are introducing the feed solution also. And evaporation will take place here, and after that vapor will be produced from the effect 1. And the liquid, the concentrated liquid will be taken out and will be introduced to the effect 2. Now you can see that in the effect 2 we are not introducing any steam again. So how evaporation will take place? Evaporation will take place because of this vapor from the effect 1. This vapor produced from the effect 1 will be used as the heat source for the effect 2. It is, I think, clear. So again the evaporation will take place. We will take out the concentrated liquor from the effect 2 and we will introduce in the third effect. And here again what will happen, from the top vapor will be collected and this vapor will be again used for heating the feed in the effect 3. And again in effect 3 evaporation will take place and ultimately we will collect the concentrated liquor as the product from the effect 3 from the bottom of the evaporator. And the whatever vapor is there, the collected, it will be collected and it will be further processed. So here we can see that we are feeding steam only once in the effect 1, but we are using it for the consecutive three effects. So here what you can see, in the case of the multiple effect evaporator, suppose here we are using 1 kg of steam, but in effect 1 also vapor produced, that vapor will be again used in the effect 2, and again vapor will be produced from effect 2, that vapor will be again used in the effect 3, and such type of phenomena will continue. So here we can see that ultimately the amount of water vapor produced in the three effects will be higher than the whatever amount of steam we have fed. So ultimately what will happen, we know steam economy is the ratio of water vapor, amount of water vapor produced by the whatever kg of steam consumed. So steam consumed is, suppose 1 kg steam we have fed, but whatever cumulative, if we collect the water vapor produced, what will happen, that value will be much higher than the given steam feed. So as a result, what will happen, in multiple effect evaporator, steam economy will be greater than the one. But whereas what we have seen in case of single effect evaporator, steam economy is always less than 1. So that's why what happens, we sometimes prefer multiple effect evaporator over the single effect evaporator. Why? So that we can increase the steam economy. But in terms of steam economy, we are experiencing the advantage, but it has some limitations also in terms of capacity, that we will discuss in the coming slides. But in terms of steam economy, what we can say, that if we use the multiple effect, then it is beneficial for us, because we can get one, we are feeding steam for one time, but whatever water vapor we are producing, that are higher than the amount of steam fed. So in terms of steam economy, it is beneficial to us. Now, another very important concept is there, that this is known as the boiling point elevation. I think in class 10, 12, you have already read about this concept, that is the boiling point elevation. So if we, you have heard about the colligative property. What happens in colligative property? If we increase the concentration of solute in a solution, what happens, as a result, some properties is also enhanced. So what happens here, if we increase the concentration of solute, so what we will see, that the gradually the boiling point is also increasing. Suppose we have taken a pure water, its boiling point at atmospheric pressure is what, 100 degrees centigrade. Okay, but suppose now within this water we are gradually adding some, suppose we have added 5 gram of sugar. So what we will see, the boiling point has increased from 100 degrees centigrade. So again, if we increase, if we add some more sugar, what we'll see, again the boiling point has increased. So from here what we can conclude, that if we increase the concentration of a solute in a solution, we have seen that the boiling point of that solution gradually increase. These phenomena, is known as the boiling point elevation. Generally in the numerical problems, the value of boiling point elevations generally is given, or otherwise you can follow the During's plot for getting this boiling point elevation. So what happens, in short we can say that in case of a pure solvent, whatever the boiling point is there, if we add some amount of solute, if we add a significant amount of solute in the solvent, what happens, gradually the boiling point starts to increase. Suppose if we have considered some dilute solution, then we can ignore the effect of boiling point elevation. But if we are considering any concentrated solution, we cannot ignore the concept of boiling point elevation. Then the boiling point elevation is significant, and we have to consider that in the calculations. Next, here we will discuss, as we have seen in the earlier slide, that in multiple effect, in terms of steam economy, it is beneficial to us, because steam economy is greater than 1 in case of multiple effect. In case of single effect, it is less than 1. Now here we will see, in case of multiple effect, how the capacity of the evaporator is being varied. So this is being shown as the single effect evaporator. Here you can see the area of this evaporator is represented by A. Now this formula is well known to you. Q is the how much is the heat transfer. This is equals to overall heat transfer coefficient into the area of the evaporator multiplied by what? The driving force. Driving force is what? Nothing but the temperature difference. Suppose here the temperature difference is the T1 minus T4. So this is valid for the single effect evaporator. Now suppose if we are considering the multiple effect evaporator, you can see here we have considered three effects. Effect 1, effect 2 and effect 3. And all the evaporators, all the effects of evaporators are having the same area, that is represented by A. So suppose here temperature is T1, here temperature T2, here temperature T3, here T4, here so here suppose if we consider like this the temperature, what we can see here in the first effect, the suppose the temperature difference is T1 minus T2. So we can write the heat transfer is overall heat transfer coefficient into the area of that effect into the driving force of that effect. That means T1 minus T2. And in second effect, what here the temperature of this side is T2 and this side is T3. Basically the side is means what is the temperature difference between the vapor phase, and the vapor phase means heat source and the feed. This is our driving force for the evaporation. So for this case driving force is the T2 minus T3. For the third effect similarly driving force is T3 minus T4. Now if we process it, what we can see ultimately overall it will become the heat transfer will be equal, amount of heat transfer will be equal to overall heat transfer coefficient into the area of that evaporators, and ultimately driving force is T1 minus T4. So here you can see if we compare this equation and this equation, the equations are completely same. That means the in terms of capacity what we are getting that, so since the heat transfer in evaporator is same, we can say that the capacity of both the single effect and the multiple effect are same. Now what if we take the some concentrated solution? So what we have discussed that in that case boiling point elevation will be a significant parameter. In that case what will happen, driving force will not be the difference of temperature of steam and the boiling point. In that case what we have to consider, the driving force will be that the boiling point plus boiling point elevation. Suppose initially it was 100, now boiling point elevation is 5 degree, then 100 plus 5 will be the total boiling point, that is 105. And the difference between the temperature of steam and this overall boiling point, that will be the driving force for the evaporation phenomena. So now if we compare these two equations, you can see in the case of boiling point elevation what happens, our driving force reduces. So as we know, if our driving force is reduced, what will happen, it will impact the overall heat transfer. So ultimately the heat transfer will also be decreased. So in such case what will happen, in case of in case of significant boiling point elevation, that means the concentrated liquor system, what will have concentrated solution, what will happen, this because of boiling point elevation ultimate temperature difference will be much more lower than the single effect evaporator, and as a result what will happen, the capacity of multiple effect evaporator will be less than the single effect evaporator in case of concentrated solution. However, in case of dilute solution, what we can say that capacity of multiple effect evaporator will be same as the single effect evaporator. I think it is clear. So if the solution is dilute, boiling point elevation is not significant, then what we can say, capacity of the multiple effect evaporator is same as the single effect evaporator. However, if the boiling point is elevation is significant, that is in case of concentrated solution, the our capacity will be rather reduced in multiple effect than the single effect. So what we have understood that though steam economy is improved in case of multiple effect evaporation, but the capacity will be reduced in case of the multiple effect evaporation. So depending upon the scenario or the given conditions, we have to choose which type of evaporator will be beneficial to us. It is not, no thumb rule is there that always multiple effect evaporation will be better than single effect evaporator. If we are getting advantage of steam economy, but we are compromising in terms of capacity. Now, in case of the multiple effect evaporation, what is happening? There are two types of configuration are there. One is forward feed evaporation and another one is the backward feed evaporation. So, in this slide, what will happen? We will discuss about the forward feed evaporation. You can see here also we have considered three effects. Effect 1, effect 2 and effect 3. How we are numbering it? Here you can see steam is being feeding in this effect. So, we are numbering it as the effect 1. The consecutive effects are numbered number 2, numbered 3. So here you can see in the same effect both the steam and feed are being introduced. In this effect 1 we are also giving steam, we are also introducing the feed. So what will happen? In this effect the evaporation will take place and ultimately vapor will be produced, that will be used in the second effect for heating, and ultimately the concentrated liquor from the effect 1 will be taken out to the effect 2. Again evaporation will take place, and similarly these vapor will help to evaporate the water content from the effect 3. Likewise, as discussed previously, the evaporation phenomena will take place. But here why we are calling it as the forward feed? Because feed and steam are introduced at the effect 1 and gradually it has been processed to effect 2 and effect 3. So as we are proceeding in the effect, that means from effect 1 to effect 2, what is happening? The temperature will be gradually decreasing. So the least temperature we will found at the effect 3. And here you can see in the effect 1 pressure will be highest as compared to effect 2 as compared to effect 3. So as the gradually pressure is decreasing with the effect, so there will be no pumping cost. Only pump will be required by to initially introduce the feed into the fast effect. But after that, for pumping the liquid from one effect to another, we do not require any pumping system. So this is clear because there is always a pressure gradient existing between the effect 1 and effect 2 and effect 3. So pumping is not required for carrying out this concentrated liquor from effect 1 to effect 2 and from effect 2 to effect 3. But here what happens, this is a one type of configuration, but now question comes, if the forward feed evaporation is already there, so what is the need of the backward feed evaporation? When we will use the backward feed evaporation? So that will be considered in the, that will be discussed in the coming slide. So suppose if we have taken a very viscous fluid, whatever feed we have there, it is a very viscous type of feed. So what will happen? Initially it is very viscous. As it is being concentrated, what will happen? After the concentration, the feed will be more viscous, and after the whatever concentrated liquid we will get from effect 2, that will be much more viscous. So whenever it will reach in the effect 3, that pumping will be very difficult for us, because gradually with the evaporation what is happening, our feed is gradually the becoming viscous, and also we know what, as the temperature is reduced, viscosity is further increased. So what we have discussed, the highest temperature is present in the effect 1, and in effect 2 temperature has decreased, in effect 3 temperature has further decreased. So what will happen? In the effect 3 the temperature is the lowest, and also the whatever feed we have got for this effect 3, that is much viscous. So this is very critical situation to handle such type of viscous fluid in by this forward feed evaporation. So in such cases what we will do, we will proceed for the, or we will select the backward feed evaporation. And another cases is also there where we will prefer the backward feed configuration. Suppose whatever feed here we have taken, that is very cold type of feed. So what will happen? The significant amount of steam will be consumed for heating this feed to increase its temperature to the boiling point. So this is a loss for the evaporation performance. Clear? So next slide we will discuss about the backward feed evaporation. So here you can see in the first effect we are introducing steam, whereas in the third effect we are introducing feed. That means we are not, again here you can see that this is effect 1, effect 2 and effect 3. How we have numbered? Depending upon the steam introduction, not on depending on the feed introduction. So feed has been introduced in the third effect and steam has been introduced in the first effect. So what will happen? So suppose if the very viscous type of feed is there, so that viscous feed has been introduced to the lowest temperature effect. So it will, what will happen? Here also when the feed will be ultimately evaporated, what will happen? In the effect 1, whatever solution we will get, that will be the most concentrated and it has the highest viscosity. But here what will happen? We will get the high temperature. So we know what, as the temperature increases, the viscosity effect gets the cancelled out. That means if the temperature is increased, what will happen? Its viscosity will somewhat decrease. So this, with the increase in temperature or the high temperature, what will happen? The effect of high viscosity will be counteracted to a some extent. And here the feed, viscous feed is fed, but as we know the third effect will have the lowest temperature, so the effect of temperature will not be significant on the viscosity. So in such cases, in case of very viscous feed, we will prefer the backward type of configuration. So it is clear here in the first effect steam is being introduced and in the last effect feed will be introduced. So what will happen here? The evaporation will take place and we will take out, or here obviously since the we are acting against the pressure difference, what will happen? We have to use the pumping system always for pumping the concentrated liquid, as contrary to the forward feed type of configuration, because here the pressure is decreasing from effect 1 to effect 2 and effect 3, and we are just circulating the concentrated liquor to the opposite direction. That's why the pumping arrangement is required. Multiple pumps will be required to work against the pressure drop of the system. So I think up to this much it is clear. We have discussed about the basic fundamentals of evaporation, and then we have discussed different types of evaporator and important performance evaluation parameters, and how the forward feed and backward feed evaporation takes place along with their advantages and the disadvantages. So today's lecture is up to this much. In the coming next lecture we will discuss about the energy and mass balance of the evaporation phenomena. Thank you.